Hello, this is Mike at Gamefromscratch, and welcome back to another hour with Blender. This hour we are going to be covering animation. In the past we've done a couple of these already, and the basic idea is to cover as much information as possible with a deadline of 1 hour on a given topic. The first one was a general overview of Blender. It walked you through hotkeys, navigating the UI, customizing things. The second one was on modeling, and then the third one was on texturing. Today we are going to cover animation. So once again, in 1 hour's time, we're going to cover as much as possible about the topic of animation. Now, I'm going to say something straight up front, 100% honesty. This is probably my weakest area when it comes to Blender. I can cover about an hour's worth of content easily, but I am no master when it comes to rigging or animating when it comes to Blender or any other application for that matter. It's not something that I really excel at or particularly enjoy doing. So I can give you an overview, but if there are some mistakes, I apologize. This is not my area of expertise at all. But there is a lot to cover. An hour is a very short period of time when you start looking at all we're going to cover. So let's hop right in this time. I'm setting up using Screencast Keys this time, so you can actually see what keys I'm using. I'm going to try to remember to also verbally acknowledge what I'm pressing as I type, but you should see down here in the bottom right corner as I... Okay, it's not turned on. Just a sec. Let me start that. Turned it on. And let's flip this over, make it a little bit bigger. And use text. So now as I click, you will see what I've done, and as I press a key, you will see what I key. So hopefully that should make it a little bit easier to follow along than some of the previous tutorials. Alright, so hopping right in, we're going to cover something about animation that has absolutely nothing to do with animation, but it is critically important. It's one of those things that you should really know to start with, and it's going to be used for animation. We just haven't had to use it yet. And that's the topic of parenting. Parenting is very important because you can make hierarchies of objects that have a relationship to each other very simply. And obviously that kind of a relationship is very important to animation. So here we go, we've got a simple cube here. And let's just go ahead and let's duplicate it. It's Control D, select it. Now Shift D. So now I have two of them, and I will move one up slightly from the other, like so. Okay, so now we have these duplicate cubes. What I want to do is I want to parent this one to this one. And it's very simple. You just select the first one, and then Shift select the second one, so they're both selected. And now hit Control and P. And you want to parent to the object. You also have this option of keep transform, which we want to do because we want to keep our initial object unmoved. If I don't, this one will move it relative to the other. So let's do a keep transform, keeps everything as it is. But now we've created a parent relationship. So this is the parent, this is the child. And this is very important because now if I grab the parent here and I move it, the child moves with it. Very critical. Whereas if I grab the child and move it, it moves independently. So if you have a hierarchy of things, for example, you were doing a mechanical drawing, you have a robot arm on a pivot, you would probably parent between the two so that when you have the one going in, the relationship automatically propagates to the children. At the same time, if I do another one and parent, like so, you'll see the relationships carry, and then again, there's no relationship between. But you could see there's a line being drawn between the two pivot points of the objects. So that's showing the relationship, this little dotted line right here. Same here, you see this dotted line that goes in between the pivot point between the child and the parent. So let me just delete the second child. But this parenting relationship is very critical to understand. So it's Control P, and then you either pick Object or Object with Transform. If you don't want your object to move, pick Object with Transform. And then you can reposition the child as much as you want, but the parent stays. Now another thing that's critically important to understand right here is this this pivot point. And it's not something we've talked about in the past. And again, it's not specifically related to animation, but it is important to animation because if I go here, let me show you from the front view. If I rotate this cube, it rotates about that pivot point, like so. All right. Now, if we have an animation going on, and I want to say rotate relative to my parent, so right, if I'm located here instead, and I want the pivot point to be there, how do I do this? And that is by setting something called the origin. You can see over here, set origin, and probably the easiest way to do it is to move your cursor to where you want your new origin to be. So I'm just going to go ahead and click here. Come on. Sorry, the widget was getting in the way. So I've now moved my origin to where I want it to be. Let's go to the side view. We'll get it arranged. Now you're going to have a little bit of a problem here because getting this moved it's just going to get into selection hell. Like you saw earlier, I couldn't do it because the widget was in the way. I could turn the widget off, make my life a little bit easier. But your easiest way to probably pivot this origin is to do it using the 3D cursor location. So what I want to do is I want to move it back along the y-axis. It's just like that. Let's check. Front is good. It's good. Now top is good. Okay, so that's where we want. We want to make our origin relative to the top corner of our parent, like so. And then once that's set, just come on over here and go set origin. And then origin to 3D cursor. So now, when I select this guy, oh, damn it. All right, now I'll undo that. Undo. I'll select this guy. I did the parent. So in the child, and then origin to 3D cursor, and now it's positioned relative to that location. So now if I do a rotate on this guy now, it rotates about that point. Again, very important for setting up these rotations. Now, another thing that we've got quite often is, let's say you have a relationship like this, but you want that rotation to only happen, like in this case, I'm only doing it about the z-axis here. So if I rotate out here, we don't want it to go this way, for example. That's something called a constraint. Again, important to 3D. Let me see. Did I screw that up? No, I'm still good. If I want to constrain the axis of rotation, it's something quite simply done. And we just go in with your object selected, and you come in here to this chain-looking guy. This is your object constraints. We'll just go add object constraint, and there's a bunch of them, as you can see. You can either you can copy the transformations from an existing object or your camera, etc. But what we are going to do is limit rotation, like so. And now that we've got that done, we'll limit rotation, and we don't want to rotate on X, and we don't want to rotate on Z. So now we've done, so we can only rotate in this direction. So if I come here and I try to go any other direction, it simply doesn't work. Now, the next thing that you sometimes want to do is limit the amount of range. So we can also limit Y. And then using this, we could specify how far in each direction you're able to rotate. So about that. So now I can only rotate. Okay, I did that backwards. I'm going to screw this all up. The logic on these is trying to prevent something called Gimbal Lock. And they've made this interface needlessly complicated. Trying to figure out, alright, where's my actual rotation up here? -14. So I don't want to be able to do any rotation in that direction, so I'm doing this backwards. Alright, 1 second. Alright, so a bit of trial and error, but basically I've done my rotate. Yeah, I can rotate up to -90 degrees. So now I'm capping it at, come on, rotate, there. So, alright, why are you not there? So that is the rotation limitation possible around this point. So you can use constraints to set different limitations in different axes. You can at any time get rid of them just by clicking there. You can have multiple constraints. You can work in local or world space. That's about it. But so between parenting and constraints, you can easily set up complex hierarchies of animations for certain limitations at certain points. That limitation will only apply to this particular child and not to this parent. So next thing we're going to do, we can actually show you something while we're here in this add constraints. Actually, I can't yet. I'm going to switch over to object mode. Go to my top, and I am going to add a curve. Now, I hate the curve tools in this program. Maybe a path will work better. Into the edit mode. Okay, I'm going the wrong direction. So rotate Z 180. Edit mode. There we go. So here's our path. Let's go here and over a bit. Here and over a bit. Okay. So what we've done is we have just created this simple path that we can follow along now. So you can click your parent. It will automatically inherit this relationship. We'll go to object constraints. We'll add object constraints, and we'll do a follow path. Our target is our path, like so. And now if I go ahead and play that, jack shit happens. Okay, what did I do wrong? Follow curve, nerves path, animate path. There we go. So now it's following along that path. Poorly. Follow curve, there. And back. And play. So you can set paths and follow them automatically with your animation as well. It's not going to be something you're going to do very, very often, but it is definitely an occasionally very handy feature to be aware of. So that's some of the very basics that you need to really understand animation, at least the simple parts of it. Parenting. Again, use Control-P to create a relationship. A child inherits the transforms of its parent, but not vice versa. The origin is the pivot point upon which transforms happen, and you can set constraints, both in the form of constraining transforms, rotations, etc., and in the forms of following path, like we just saw. And I can also go ahead and get rid of that. And we're back. Actually, I can get rid of all of this because we're going to move on now. What you saw down here, this is actually what I'm going to show you next. This is the timeline. This is probably the heart and soul of animation. And we need none of this. Let's just get rid of everything. Go back to a default scene. There we go. So this guy right here is your animation timeline. Basically start at frame 0 and go up. The speed of the actual playback is up to you. It's set here in your frame rate. So right now it's at 24 frames per second. If you prefer, you can set this to 30 or 60, and it'll correspond with how your playback rate will be here. I think it will display even with nothing set. So you see up here, it's showing you the playback speed. I don't know why it varies off of 30 every once in a while, but that's what sets this target. So if I sit here and said make this 60, it will try to hit 60 in this frame per second playback. So your frame rate is controlled up here, but your frames are controlled down here. And this is your timeline. Your default right now is starts at 1 and ends at 250. So if we want to have it end at 100 instead, just do that, and then boom, we've got 0 to 100. Now this timeline right here can be scaled using your mouse button, like what you see here. It can be panned, holding down the middle mouse button and back and forth. But essentially, this represents your various frames of animation. And what you use normally within those is something called a keyframe, which we're about to show in a second. Very, very important aspect to understand. But basically, you go from frame 0, which is often your pose frame. So here's your first frame of animation, your last frame of animation, and this blue line is your currently displayed frame of animation. You've got VCR style controls right here, so I can pause it at any time. You can go back a frame. There's no keyframes to jump, so I'll show you that in a minute. Or beginning and end. Now, we're going to do is show you now that keyframing process. And in order to do that, I need an object. So let's bring in a monkey. Add object, mesh, monkey. All right, so here is our monkey in our world. And what we now want to do is be able to animate it. As I mentioned earlier, this is done through a process called keyframing. If you've worked in graphics at all, this is also probably similar to something called tweening. Very similar concept. Basically, you tell the computer, this is a keyframe. This point of animation, pay attention to it. And then this is a keyframe. So somewhere down the timeline, so you say at 0, this is an important location, be aware of it. And then say I jump up to 25 and I say, okay, now this is a keyframe, be aware of it. And what the computer will now do is interpolate or mathematically lurk between the first one and the second one to create a smooth transition between the two. Now you've got some control over how that transition happens using something called fcurves. We'll see that in a moment. But basically the way keyframe works is instead of, if you think about it, if you have 30 frames a second of animation, 3 seconds of animation, that's 90 frames. You don't want to position 90 times. It's like stop motion claymation, where you actually have to set each frame over and over and over and over again. Well, computers are smarter than that, and they can do the in-betweens for you. So what you just need to do is go, this is a critical pose, and this is a critical pose, and it will do the math for you. Now, you have to give it enough information so that it can figure things out. For example, if you were doing a helicopter rotor, and you said, okay, here's frame 1, and then in frame 2, I want to rotate 360 degrees. So you do that. So you make frame 1, and then you rotate the prop 360 degrees as frame 2. It's not going to be able to figure that out because the 360-degree rotation over that period of time is nothing. So it's not going to rotate it at all because the change or the transition state between the two isn't going to work. So what you would basically have to do is either do 2, 3, or 4 keyframes in between. So you do, say you did 4. The first one you set it as a normal position. The second one you'd set at 90-degree rotation. Third one you'd set at 180. Fourth one you'd set at 270. And then finally the last one you would set at 360. Then it can interpolate the full circle and have it in the right direction. Whereas if you use less, it can't necessarily guess the direction you want to go. So you have to give it enough information that it can logically figure out what can be done in between. But for the most part, the computer is remarkably good at calculating those things. So let's do that. And then what we're going to do with this guy is we're going to do a scale. So we'll start at the very first frame, and we want to set it so that this is how it stands. So that means we have to keyframe the initial frame. And that's a matter of, to add a keyframe, hit the I key, and it brings up this menu. It's this Insert Keyframe menu. So what you want to do is I. And then you'll notice there's a bunch of different things you could keyframe on. Location, rotation, and scaling. All individual. So you're doing a location keyframe, a rotation keyframe, or a scaling keyframe. But you can also do combinations. So lock rot is location and rotation. Lock scale is location and scale. And lock rot scale is location, rotation, and scale. So if you're capturing, I'm generally lazy and do a lock rot scale. You probably shouldn't because you're doing 3 times the amount of information that you need. But computers are fast these days. I don't know if there's a downside to doing it my way. But if you're just scaling, you should, in theory, just keyframe scaling. All right, so that's what we're going to do. So we've got our initial guy. What we want to do is we're just going to set a scaling keyframe on it as it stands. So we've not done anything with it, and we'll just go I and hit scaling. Okay, so we've just done a keyframe on it, and you'll see over here that the scaling is now lit up in yellow. That means it's controlled by a keyframe on this particular frame of animation. And if I move off of frame 1, so we move away from frame 1 to frame 2, you'll see now on frame 1 there's a yellow line here. And this shows that there's been a change, but not that there's a keyframe. So watch, we'll go back to frame 1. Oops, I did a reverse play. Let's go back to frame 1. So you can go here and enter the frame directly, or you can just click it. You'll see yellow means there's a keyframe controlling it, and then green means that it's changing, but there's no keyframe on it. So we set a keyframe here, and now let's do this across the entire course of the animation. So at 100, we'll set another keyframe, but this time, so we've got it set here that we're editing 100 now, and we'll just grab our guy here, and we'll do a scale, S, and move the mouse out like so, and now I hit I again, and I pick scaling. Okay, so now I have set 2 keyframes, one at frame 0, one at frame 100. Let's go back to the beginning of our animation and press play. And there is the result. So the computer has calculated the in-between frames as it's needed. And we can throw in another frame into the mix here if we wish. So say let's go to 50, and we'll rotate Z-axis 90 degrees. And then now I'll insert a rotation key in there. And now let's see what happens. Go back to 0, like so, and press play. So what happened there? Well, we didn't have an initial set key position, right? So our animation had no idea what to rotate relative to. If there's only a single key, it will apply accordingly. So what we had to have done there is instead set a key at 1 as the non-rotation. So remember when I did the scaling thing, I set a scaling key, but I did not set a rotation key. So that rotation key being the only one, there's nothing to transpose between. It automatically just applies itself. So it's important to understand with the keys, they are a relationship more than anything else between 2 different states. So if we didn't want it to just do a rotate, which obviously we did not want to do, we need to set a rotation key here. Now this might actually, oops, Let's undo that. All right, so we set -90 rotation here, which we probably don't want to do, but it should let us get away with this. We'll set a rotation key as well. So now we have two keys set here. We have the one key set here and the other key set here. We go ahead and play it. There. So you do need the two different keys to for it to extrapolate the information between them. So just setting one, that transform will be basically universal. So these keys are very handy that way. Now let's look quickly at editing them. Pop that down. Or do that. There's a couple of handy tools built in that you probably haven't used yet. First one is your dope sheet. A dope sheet is a very top level look. You can get into a point where you have hundreds of keys, hundreds of things being keyframed, especially when you start talking about bones and complex scenes and such. This is sort of your top level view of all of them. And what you're seeing here are all of the different keys that we've set over the course of our animation. So you see here, here's Susan. All the actions applied to Susan, our monkey mesh. So we've got our scaling key, our first and second here. So you can see the same timeline, and once again you can scale the timeline using the scroll wheel if you wish. Same tools apply. Oops, let's scale that back up. So you can see at the frame 1 and the frame 100 keys for your scaling key that you set, and your rotation key at 1 and 50. Now, if we wanted to, we could go in here. Right now, they're all selected. You can see by the yellow, so hit A, and we'll have none selected. I could grab a single key like this, the rotation key, second one, and I'll just hit X and delete it. So now we no longer have the rotation in our animation, like so. Now, standard undo applies, so I can now hit Control Z and bring that key back. At the same time, I could also, let's see, one sec. I can also, with that key selected, move it. So right here with it selected, I can just hit the right click and hold, and now I can move that key down the timeline. Let's move it to, say, 7. Hey, move. Come on. Right click and hold. And left click to commit. So now that key is at 75, and the animation will change accordingly. Now, another thing that is done right now is the way that the animation applied was linear. So basically, from this point to this point, it just did a transition, very smooth. So it did it, probably what it did is it took this rotation between 0 and 75, divided it into 75 or 75ths, and applied that much per frame. Now, sometimes you're not going to want to do that. Sometimes you're going to want to have it more towards the end or more towards the beginning. And that is where something called an F-curve comes to place. And here you can see your keys in a slightly different view. Let me just pause the animation because that's getting confusing. An F-curve is showing the transition of your keys over time, per se. Let me just... Yeah, we'll just look at the rotation key. So we'll turn off we're just hiding the scaling key. So there's your rotation key. And here is frame 1, and here is frame 100, and here is your current position along it. And here, scroll that down, is the transform controlling that rotation. So as we come back to here, you'll see there, and basically done. So this is the smoothness of that rotation action. And we can tweak that as we want. If you've ever used a Bezier curve, here's your Bezier curve control handles. So we can tweak it how we want it to actually appear. Right click, and we can right click. I hate these controls. Right click and drag, and the left click commit. Right click, and come on. So now it's going to be a much more abrupt rotation, and we will show you. Zoop and zoop. So that increased rate that you're seeing right there as it jerks in, that's this transition that we've created. So this is how this smoothness, so the slope of this line is ultimately determining the transition between those two keys. So you can use the F key to basically, the F curve keys to control how those transitions between the smoothness that happens between two keyframes in an animation timeline. Now, I am only touching on a very small portion of it. There is a lot of things you can do. You can set your easing in, easing out between points. You can change the way your handles work. You can change, you can have F-curve modifiers built in. You can actually do your keyframing directly in here. I'm not going to touch on any of this stuff right now. Again, this is not really an area of my specialty, so I mostly just want you to be aware of it and understand what it's there for. And more or less, this is for transitioning between two keyframes. Okay, so that's what your F-curve is. Your dope sheet, again, is more of a top-level overview, so you can move keys in the timeline or delete them if you wish. There is, of course, more functionality built in here, but I am not getting into it. You can copy and paste between keyframes, etc. But again, I'm not going much more deep into that. Okay, so that is keyframe. You can set a keyframe, quick overview. You can set a keyframe on location, position, or scale, or all three, or any two combinations thereof. They are set over time. Now, one thing that I didn't cover here, and I shall go ahead and do so now, is this process of setting these keys is kind of a pain in the ass, especially if you've got a whole lot of them. Well, you can also have it set to set them automatically. Once you've set at least one key, you can set auto keying on. And let me just pause this guy. So let's say I move here. I can turn this record button right here, like so. And now that movement, see what I did? And now when I press play, so now any movement you do in the scene will automatically will get keyframes. So any scaling, rotation, or actually I haven't done any rotation in here yet, so I can show you. So right here, new key, new position, and I'll just do a rotate like that, and you'll see if I move away from keyframe 25, that was automatically created. So if you've got this record button on, once you've created, now if you haven't created a keyframe yet, so if you haven't done generally this keyframe right here, your base position, this button will do absolutely nothing. But once it is set, this will automatically capture any movements you make as keyframes automatically. It keeps you from having to do the insert, the I key setting. And now if I go ahead and play that, you will now see all of those things are being applied. So that's what this guy is. This guy's an automatically set new keys as you're moving things around. Okay, so that's keyframing and your timeline. And very, very quick, very brief, very kind of pathetic overlook of F-curve and dope sheet. But that's what all those tools are there for. One is a top-level, quick editing of all of the kicks. Like I said, your scenes can get very complicated very fast. And then the F-curves are more for transitioning between two keyframes, for smoothing in, smoothing out how the actual keyframes, the relationship between them is. So now we're going to look at a very important concept called bones. Now, something I haven't really talked about here that's important, especially because, again, this is a game from scratch. You're probably here as a game developer. Blender supports something called nonlinear animation, which means basically you can have these parallel timelines that you can all blend together. So what I can do is I can create a walk, a jump, a fall, a die, animation all in parallel and blend between them. And this works wonderfully, except outside of Blender. Once you start exporting these named animations, they're sometimes called, or nonlinear animations, once you start exporting those out to other game engines, they're often not supported. And what generally will happen is whatever the zeroth or the very first animation is, will be the only one visible. And what happens here, and this is changing, I believe Collada and FBX exports are working towards fixing this if they haven't already. But what you generally will do if you're exporting multiple animations out of a tool like Blender, and this is the Max and Maya way of doing things, is you add them all in the same timeline, or you do them as separate exports. So if you have a jump and a walk, you would say do frame 0 through 40. This chunk right here is your walk. And then at 40, you would go back to your standing frame, your base frame, and then from 40 to say 70, you would do your jump animation, and then from 70 to 100, you might do your crawl animation or whatever. So basically, you just do all of your animations back to back to back. However, there is support in here. I'm not going to really cover it for a couple of reasons, but there is this built-in nonlinear animator, and you can come in here and create tracks like run and then jump and then you record each kind of a timeline for each one of each name, and they can all be exported in parallel or worked with in here in parallel. But that again isn't universally exported when you're bringing it out to Unity or Unreal or any other 3D game engine. That will often kind of lead you into a trouble point. So it's not always a recommended way to go. Okay, so that's gone. Another thing that's key, what we're about to show now is something called boned animation. And that is you're going to have an armature that controls how the mesh is animated. It's very cool, and initially it's very simple. However, this is the way most game engines support animation, and sometimes it's the only way. So a lot of exporters will have, even if you have like a ball bouncing, you need to create a bone for it, even if that makes no sense at all. And your bone basically controls all the vertices of the ball and does nothing bonish, but that is just how a lot of game engines do animation. They will support bone animation only. So what we saw earlier where I was doing the parenting between the two boxes and then setting keyframes as they move around, a lot of times that export will not work right with the animation system you're exporting to. So you're going to probably, if you're working in game engines, be doing boned animation. And let's look at that quickly. So let's just clear that guy out. I'm going to create a very simple mesh that we're going to be able to manipulate with bones. And I'll do like a kind of an arm, a one-fingered arm. So add mesh, a cube. All right, so we are front ortho. Let's go to side. All right, and come on, and face, extrude, extrude, scale, extrude, scale. Extrude, loop cut, loop cut, loop cut, and loop cut. And turn X-ray off, that's getting confusing. Face, extrude, and scale. Alright, so this is our very crappy hand and mitt arm. I know it doesn't matter, but let's scale that down a little bit. Okay. All right, now just being pedantic, but I'll scale that down slightly too. So there is our arm that we're going to control. Now, at this point in time, nowhere near enough. And this is an important topic when it comes to bones. If you want a smooth transition, especially at your joints, like you think of your elbow, your thumb, whatever, there needs to be enough geometry there to work with. And I'm just going to quickly apply, let's go to Edit, select everything. We'll just do a double smooth apply. So there is our really crappy arm mesh. And now we want to go ahead and animate this mesh using an armature or bones as you wish. So let's leave object mode. We'll kick X-ray back on. And we're going to want to start right about there. So I'll just move my cursor there. I think that's about the right spot, right? Yeah, that looks good. No, it doesn't. Let's move our cursor back just slightly. So that is the y-axis. Okay. That's not where I want to be anyways. Okay, just 1 second. Okay, so we want to start our bone here. So now we're just going to go in here and go add, and then armature, and you don't have a lot of options here. Single bone. So now if you look at it, it has created our bone, and our bone has two ends. You got the root, and I forget the terminology here. 1 second. Okay, you got your root and the tip, And this is going to be the base of our bone chain. A lot of times what you want to do is ultimately have, if you're doing a human, the top level will often be your hip, and you'll radiate out from there. So we've got our bone here going out that way. And we want to do, come on, there we go. I didn't have focus. We want to actually rotate it so our bone is going this direction. So we'll rotate Z. Oops, not Z. Control Z. Okay, what have I done wrong here? Our bone is looking at a very weird angle. Ah, that's why. Okay, so we actually want to rotate Y 90. And we want to move it down like so. So you see our bone is now inside of our arm in all directions. So what we now want to do is go into edit mode like so. And you can now select between the root and the tip, and we're just going to take the tip down. And you'll notice it's automatically scaling the shape of our bone. There are a couple of options of how we want to display the bones if you want. By default, it is using an octahedral. The shape right here, you can set it to use lines, you can have it use squares, or you can have it use, where are the options? 1 second, I'll show you. We can set it here. Nope, that's not where you set it. Okay, sorry about that. You set them over here in your armature settings. So if you want, you can switch between octahedral, stick, B-bone, envelope, and wire. Octahedral works for me. The shape somewhat visualizes the effect. I don't think there's really any real effect when you change between these things. Yeah, pick whichever one you like. So what I'm going to do here is I'm going to set, so our bone starts here and ends here. So you can think of this here is the bone. And that would be like your upper arm. So now with this tip selected, I'm going to just go ahead and do an extrude X, and we'll bring him out this way to about the wrist, like so. I'm going to switch over to the top view. Oops, I missed by a bit. Like so. So now we have a bone here and a bone here, and I'm going to do an extrude out, and then down the thumb thingy here, and then we'll select this bone again, and we'll extrude out this way. So now we have a bone here, a bone here, a bone here, and a bone here. Again, this is the parent, this is the child of here, and the parent of, so this is the child of here, and so on. The hierarchy works that way. Now you can create another entire chain of these and parent them as we did earlier, and they will follow the position of their other parent bone. So now let me just make sure that we're entirely inside of the mesh, which we appear to be. All right, perfect. So now let's switch out of edit mode. So once again, to actually make these bones, to extrude them out, again, extrude was with the E key. I don't know if I said that or not, but you just select the tip and then do E to extrude and drag it out, and that's how we created this. But that's all just like editing a mesh. There's editing of bones. So we'll go out of edit mode and back into object mode, and there is the bone structure we just created for our mesh. So it's already selected. I'll do it again anyway. So there, make sure you've selected your armature. Now with your armature selected, select Shift, hold down the Shift key, and select your mesh, like so. And now hit Control P. Oops, sorry. Select armature, mesh. Am I doing that backwards? I am doing that backwards. All right, mesh, armature. So you're parenting the mesh to the armature, and then Control P, like so. And now you've got a couple guys here that weren't there before. So I didn't make that clear, so I'll just do it again. Select your mesh first, then shift-click your armature. So you've got mesh, then armature, and then select Control plus P for the parenting, exact same as before. But now we've got a couple more options. And what I'm going to do is say automatic weights. And what this is going to do is bind each bone to the vertices of that polygon automatically for us. And you'll see exactly what I mean in a second. So we'll just go ahead and pick that. So now we have parent-child relationship of this mesh. We have bound this mesh to this armature. So now if I move the armature, the bones go with it. Okay. Now where it gets really cool though is now with this armature selected, I go over here. The armature had edit mode that we were in before. This is where you edit the bones themselves, but it also has pose mode. And in pose mode, now when you select a bone, like so. You've got your bone hierarchy here. Well, if I grab this bone, it's the parent, so you're not going to see too much different. But if I grab this one, and I do, say, let's do a rotate around the z-axis, see what happens? That is deforming the underlying mesh. That is very cool. So I will show you. Oh yeah, I deleted all the lights. The mesh itself deforms to go with it. Now, when I told you earlier that you need to have enough polygons at critical joints to make the rotation, to make the animation smooth, this is what I meant. So if you look, so I'll actually show you on the thumb. So on the thumb, let's say here, when I rotate this guy, if there isn't enough detail, you'll get a kink or a bend right at the joint. So now we can drop out of post, because I've created a weird sort of hierarchy here. Let's say I want to move this guy over a little bit. We can go back into edit mode, and all the animations you just did will be undone. So they're still there. So we go back to pose, it'll still be there, but only in pose mode. So go back to edit mode, and this is where we're editing the structure of the bones. So we're just going to grab this guy here and drag it out slightly, just to get the influences done a little bit different. So make sure that this guy doesn't overlap with that guy. So there we go. Now we're going to switch back to pose mode, and we're good. And now, again, I could grab this guy and do a rotate, and you'll see where it's influencing. Now the key thing is, you see how there's a bit of a fall off where the mitt and the thumb are sort of fighting for influence. And influence is a critical word here, because that is, that's where that, when I said parent this with automatic weights, that's the weight. And I will show you now, there's a bit of a dance involved here, and I'll do it from the very beginning because this is confusing. So we'll leave object mode. We'll go back to object mode for it. Okay, so if you want to edit the weights, you can do this using the handy paint tool that's built right in, or you could do it manually if you really wish. But the process of getting it up is a little convoluted. So first thing you want to do is come in. I want to select nothing. Okay, so first thing you do, grab your armature, like so. Then you go into pose mode, like so. All right. Now you select your mesh, like so, and you switch over into weight paint, like so. So now what you're seeing here, this is the influence that this bone has over the underlying mesh. And now, if you didn't go through that process, you're not going to be able to click bones like I just showed you. So that's why you had to select, go into pose mode, and then select. So now you can right-click and get the underlying bones. And you'll see the color map in the background, this red. Anything that's red is 100% influenced by this particular bone. So this bone has influence over this guy here. This guy has this guy here. And then you get into this yellow and green, and that's the transition between the two. Now it's set up automatic weights. The nice thing is that means there are no orphan vertices. There's not, you can run into situations where if you even miss a single vertex when you're painting weights manually, it will not be influenced by the underlying bone, so it goes insanely stupid. So that's what you're doing when you're coming in here and painting. So if I wanted to, say, extend the influence of this bone, this mitt bone, to be a little bit more strong on the I don't know, the webbing in between the thumb and the hand, just come in here and then paint. And this red, so I'm just adding influence over that bone, like so. And so on. Now let me just exit out. All right, what did I do? Exit out. What am I editing? Object mode. Okay. So that is the weight painting. So once again, a bit of a recap because that is a little screwy. If you want to be able to select the bones while you switch, if you don't, if I just go in here without any of these selected, it will automatically, I think, select just this one. So if you want to be able to switch between bones while painting weight influences, just select the armature, go into pose mode, then select the mesh, just right click, select it, and then go into weight paint. So now you'll be able to switch between the bones. And all you're really doing here is setting the influence of this bone, how much this bone's movement will influence. So if I go here, again, I added a bit more control. So now I'll go back to my pose mode. So ultimately, here, let me get out of weight paint, back to my armature, in pose mode. So now if I move this guy, you'll see it's got more influence on what's happening with this particular joint. And as I said earlier, you can have this entire hierarchy. Here, I'll use a non-bone as an example. Let's get back into object mode. So you could take this entire armature, and I'll just go in ahead and add a lot of cube. So you grab armature, got armature, and then cube, and we'll parent, keep our transform. So this could be another armature. It could be a different controller or whatever. But now, if you move that cube around, the entire armature goes with it and is influenced by it. So what you'll see a lot of times, and this can also be done with the constraint settings. You can set child of, etc. But we don't actually need it in this case. But you can see there is the relationship once again being drawn between the armature and the parent. And this is parented to the armature, so the mesh will automatically follow, and so on. So you can create very complex hierarchies as you go. Now the important thing where this all strings back together is, let me just get rid of that relationship. This arm now is completely animatable. So what I can do is I can come in here, select this armature, I'll go to frame 1, we'll go into pose mode, we'll do a select all, and I will do a loc-rot scale. So I've just set a bone, I set a keyframe for every bone in this armature. And now you can do things like, let's go to frame 25, we'll grab this guy, we'll rotate it z-axis this way, and this guy, rotate z-axis this way, rotate z-axis this way. Again, select them all, hit I, loc-rot scale, and then we'll do again at 50, say, and we'll do a rotate there, a rotate there, and select them all, once again, loc-rot scale, and if I now do a play, we have a smooth skeletal transmission animation going on. So that is your armature. These bones on the inside are now controlling your animation, but you're still using the same process you did before. You set your keyframes, you advance your timelines, etc. And there is your ultimate animation. Then you come back again, we'll split this window open. You still have, and you'll see we've added a lot more here now. So your dope sheet is here. You can see it broken down for all of the bones, and for each bone, you can see the settings for all of the different settings within your scaling, your rotation, and your location for each bone. You broke it down, and then here is each keyframe we set across our timeline. And again, we go over to the graph editor, and you can see the function curves for each bone. And if you want to just influence a single bone, of course, you could hide the other ones, and that is just for bone 3, which I believe is that. I don't remember which order. It's going to be one of the 2 hand bones. So you can change the transition between each keyframe of the bone. You can bring that down. You can see each one, it's color coded, graph line here, and that's how you can smooth out the way that the individual transforms happen between each key. Yeah, that's about it for bones. Ultimately, you build your bones up together. This is how you make just about anything, to be honest. It doesn't have to be complex like this. This is how you would do. Any human is generally animated by bones, including even your facial animation quite often will be controlled by bones. But there is another way, and we're going to see that in a second. We're going to finish off with that, to control shape changes, I suppose we could call it. But this is essentially how most animations work. And you could have it sometimes where you have a game engine that only supports bones. And let me show you very quickly how that works. Very simple process in terms of dealing with everything. Now this is very distracting while this is going. So we just select everything. Oh, edit mode, object mode, select everything, and delete. Fresh scene. Now let's say you did have something like a jet. You wanted to do, I don't know, pre-scripted rotation animations or whatever. So I'm just going to bring in, or a bouncing ball. Bouncing ball is easier for me. So I will just come in, bring in my ball. And so this is only for game people, but if you need to have bone animation to support, so I can't just sit here and go set a keyframe and then move it and then bounce it and so on and so forth. I need to have an underlying bone controlling it. It's as simple, literally, as that add. Let's go click so that we've got our cursor there. We'll add our armature to the scene, single bone inside of our ball. Let me just position it slightly better. like so. And this is X-ray. And now we just want to grab our mesh, click our bone, parent it, and automatic weight, like so. And that is how you would now animate. So instead of animating the ball, just animate the bone. But otherwise, it is exactly the same. So if you have a single bone object, it's fine. And your game engine will now deal with this guy just peachy. So I'll go back to here, frame 1. And now let's say we want to go ahead and do, here, we'll set a key for everything. And then frame 25. And we will move it up here. Being lazy, I'll set a key for everything. Frame 50. We will go back to here, set a key for everything. 75, back up, set a key, everything, and 100. Back down, set a key, everything. Of course, you could have add a bounce, add a squash, whatever that you want on here, obviously. It doesn't have to be limited to that. But now you have this very simple bouncing animation that will now export and work in any game engine that supports bones. So that requirement, that bones requirement that some game engines have, isn't as limiting as you think. It just adds an extra step. You can't just animate the object itself a lot of times. It has to be parented to a bone, and then the bone does the animation. But you see, there doesn't need to be a relationship. There doesn't need to be multiple bones. Just make sure that that single bone has control of the entire mesh that it's parented to. And once again, if I go into this mesh and I go to weight paint, you'll see it's just entirely red. And I will quickly show you, how do I erase? All right, let's go here and subtract. There. So now we have areas that are not influenced by the bone. Remember I told you earlier, if you had orphans, you're going to have issues. All right, why don't I have issues? Oh, maybe it's because there's a single bone. So I might need to actually have a second bone to show you. Do this quickly enough. All right, come on, bone. Yep, edit, tick, extrude. All right, that might be enough. And now if we play. All right, so now let's do a parent. Parent, automatic envelopes. Go into edit mode here. Go into pose mode. Click our mesh. So why are you? All right, not at all what I wanted. All right, bad example. But anyways, if you have a portion of your enveloping mesh that is not actually directly controlled by a bone, it should be going. This is a very bad example because it's not working at all. Let me just show you quickly what it'll do. Is on your frame. It will basically do this. It's not what you want. So the uncontrolled vertices are basically left behind. I'm not able to delete. I'm deleting them wrong, so you're not actually seeing that in effect. But that's what will happen if you get this weird artifacting as you're animating across. It means that one of your vertices is not properly controlled between the underlying bone structure. Okay, we got one final topic to cover. Then we're sitting at the 53-minute mark, so that will give me just a perfect amount of time for a recap if I don't screw this up. So let's do that. So let me just select, let's go object mode, get rid of that guy, fresh new scene. And let's put our cursor back to about 0, and object, add, and we shall add us another monkey. So I'm going to subdivide that guy too. So there, got a bit more detail. Here you go. Nice monkey. And so, looks good. Now, what you sometimes want to do is animate features. As I said earlier, sometimes a face will be controlled with a bone, but sometimes it will actually be done in other languages. It's often called, or other programs, it's often called a morph target. Here, it has a different name, and that's a shape key. If you go over here to the Object Data tab, this triangle, you will come down here and notice there is something here called a shape key. And let's go ahead and set one. It's sort of like when you have your timeline, you have your base frame of animation. Well, you also have your base shape key. And let's set that. And we now have, I did it in the wrong section. We'll go ahead and delete that. Under shape key, so let's just get rid of all of these guys. Shape keys, hit the plus. And now you have the basis shape key, or your base shape key. And now what we're going to do is go ahead and add another one. like so. So what I can do now, I have this key 1 and basis. And this is now I can manipulate the geometry of our object. And we'll call this one, say, wink. Okay, so now what I can do is I can go over here into edit mode. And let me just quickly go into proportional edit and enable. Oops. We'll just circle select that geometry right there. Oops. I did not want to select you. Alright. Let's do this again. Circle select. We'll grab that geometry there. And all that we're going to do. Alright. Let's try this one more time. Circle select. Circle select. Select the geometry. Remember to right click so it's committed. Now we just want to drag that up. World's worst wink, as my influence was way too big. But that'll work. So now we have this double set of geometry, this modified one for wink, and then basis. So basis and wink. Basis and wink. Now you could create a bunch of these. You can create pretty much as many of them as you want. You could do a smile, you could do a pout, just basically manipulate the geometry however you want to actually influence. Keep the underlying geometry the same. Don't be subdividing or anything. You're working with the same geometry set, but you can move it around however you want. So we've got the world's worst wink would be there. Okay, so now what we can do is animate this over time. We can do set basis here. So I'll grab wink. Mine's still in edit. Okay, back to object mode. So select wink. Again, keyframing, basically. So we're on frame 1 right now. You come over to this value, and it's at 0. Now just right-click this guy and insert a keyframe. So now we've set at frame 0, wink at 0. And as time goes on, let's say at frame 25, we could set it to 100. So this is 100% winking. And now we just wrong-click, right-click again, insert another keyframe. So now you see it's gone yellow. Same deal as before. So if it's being changed, it'll show us green. If it's a keyframe, it shows us yellow. So we've just set that value as on 100%. And now at 50, we'll dial it back to about, say, there. Right-click, insert a keyframe. And then at 75, we shall set it back to 0. Right-click, and insert a keyframe. So this is how you would often do facial animations. As other things, finessed, I guess you could do, I don't know, basically it's localized geometry changes over time. And that's exactly what we've just done. So we've set these multiple keyframes. Now let's go back to our very first key and see the result. So there, world's worst wink, but obviously you could spend more time with it, change the geometry as you wish. And this is how you would use shape keys. And you could set multiple shape keys. I could have 9 or 10. I could have a wink and a smile, and I could apply both of them over time and then do a blend between them. I don't have multiple, so I'm only showing you a single one, but that's basically what shape keys are for doing very fine-tuned geometry level animations. And once again, same process. Again, it's keyframed, but as you're seeing, you're keyframing the percentage value. So you just I could add another one if I wanted to. Just click here and do plus. Just make sure you set that basis key. That's your default, your beginning. So that sets your basis. So this is shape keys, used very handy for doing over time fine level details. Like I said, you could do a smile, a wink, a frown, a grimace, a nose curl, and then you could blend all of those together, apply them and do animations over time and create very complex facial animations very simply. So that's it. That's actually probably enough on animation to get you started. There's a whole lot more. It's a huge subject. Look, keep in mind, a technical director or an animator is a job. There's people out there whose job it is to basically, a technical director often creates rigs for a living. So remember back when we were doing that, extruding the bones, that setup, well, and the constraints, etc. That is somebody's job at least at a movie house, sometimes even at bigger game places. So there is a lot to learn here. This would also probably be set up by a technical director who would then make a control interface, and someone would instead use sliders to do this stuff. And this constraint could be linked to a slider in the scene or an object in the scene external that you then use to control particular things, but way beyond the scope of what we're talking about here. Essentially, though, the key things to pull apart or to take out of this, I'm going to slightly go over my 1 hour, unfortunately, because I'm about to hit it now. So we're just going to do the recap now. First thing to learn was parenting. Control P brings up the parenting menu. The child will automatically inherit the parent's abilities. The next up, positioning. You choose transform if you want to keep your transform or not. So Control P brings up that menu. And those relationships are critical to understanding animation, because even when you're creating these bone hierarchies, you'll also ultimately be parenting one hierarchy to the next, to the next, to the next, and then generally parenting all that to a null object that you use as a control structure. So parenting, very important. We looked at constraints, which you can apply using the chain control here. Do things like constrain rotation in a certain axis. We also looked at the origin, which is the pivot point of an object. You can set it by setting the 3D cursor and then picking set origin through 3D cursor. Now all the transformers will happen relative to that location. By default, the origin will be the center of the geometry, or the center of the geometry as the geometry was created. If you modify the geometry and want to move it back to the center, you can actually do that by going set origin, center of mass. But the origin is the transform point. So when you're parenting something, the child parents relative to their origin. So origin is another thing that's important to understand. We also looked at keyframes. Keyframes deal with this VCR type timeline. Your keyframes are these yellow dots that are basically saying this is an important position at an important point of time. You figure out the rest. So you set keyframes for values for location, rotation, and scaling, and it does the rest. You can set for 1 of, 2 of, or all 3 of those values. You can also set keyframes on things like this 100% control over here. Then we looked at bones. Bones are created as an armature. You just add an armature to the scene, and then you parent the geometry to the armature. And then you can set the armature's positions using pose mode. One thing I didn't touch on, but is important to know, is when you're in edit mode, don't scale bones. Bad thing, causes problems, just don't do it. So use them via edit mode. You can position them, but generally you don't want to scale bones. You also generally don't want to scale bones in object. Basically, if you can help it, don't scale bones. Causes problems. So bones are then animatable using the pose mode. Again, you just set the bone position, and then you set a keyframe. Hit the I button, and then pick the elements you want, location, rotation, scale, that you want to set a keyframe for. Or you can also, once you've set at least one keyframe, you can set this automatic keyframing, and then any changes you make in pose mode or object mode will automatically be captured as new keyframes. Be a huge time saver. It can also create huge pains in the ass. So it's a selective tool, but it can basically, if you know that everything you're doing is being recorded, it's a huge time saver too. You don't have to hit I and then pick, I and then pick. Now, one thing you'll notice, and you may not until you do it yourself, but when you hit the I, it will automatically select the previous choice. So you can just do I, and it will automatically set a key for, if you did location, rotation, and scale, I will automatically pick rotation, rotation, and scale. So it does get fast. It's not really a huge slow down thing to set. And then finally, we looked at shape keys. Shape keys allow you to make basically different poses of the underlying geometry and blend between them. It allows you to do things like create smiles, create this horrific wink that you're seeing in front of you, etc. Shape keys are pretty powerful. Now, one of the challenges, your shape keys aren't going to be guaranteed to be exported to your game engine. So if you are ultimately exporting to Unity, Unreal, etc., you want to check to see if Blender shape keys are or aren't supported. It's probably a coin toss if they are. I can't tell you right now without doing some research, but look into that, if you can even use shape keys or not. Now keep in mind, what we just did here, this could have just as easily been done with a set of bones underneath this mesh, and I just move the bone up and remove the underlying surfaces. But shape keys are a lot easier to work with and a lot easier to blend between. It's the blending between them, the wink and a frown, that kind of stuff. Being able to do all these things together, that's where shape keys start to look really powerful compared to bones. But bones can pretty much accomplish everything a shape key did. And as you saw earlier, even if you have a simple single object, you can still bind it to a bone, as a lot of game engines will require. And the only thing that's going to change for you is when you're setting your keys, you're setting them to the bone as opposed to the object. But otherwise, it's quite consistent in behavior. I think that's about it. We very briefly looked at the dope sheet, which is a top-level view of all of the bones in your scene, and the F-curve, which is your transition between point A and point B via editing curves. very, very briefly touch on that. If you are an animator, that is an area where you spend a lot of your life, and I very briefly touched on it because I am not an animator. I'm showing you the tools, not necessarily the best expert at actually using them. Anyways, that's an hour and 5 minutes. Sorry I went over again, 5 minutes over, but it was a lot to cover. I hope you now have a better understanding of how the animation tools work in Blender. I should have probably covered the NLA portion better, so you could create multiple named animations in the same file. I may do that as a separate post a little bit down the road. So if you actually want that, let me know in the comments, and I'll do a quick post on it. Okay, I hope you've enjoyed that. Thank you.